Ram said we'll save the best for last. The downside is many people are drinking. So why don't we get started? How many of you have been following Nvidia? All of you, right? So ChatGPT came out about 2 years ago. Over the last 2 years, all of training and almost all of inference has happened in the cloud. As we move forward, training will remain in the cloud. Inference is moving to the edge. So what is the edge? Edge is your smartphone, your PC, your wearable, your car, your robot, and devices that have not been invented yet. So on this panel, we will talk about how on-device compute is moving to the edge, how inference is moving to the edge, and what that means for all of us. Make sense? Make sense? Okay. So let's start with quick intro. We are going to wrap at 4:45. So we'll run a very fast-paced panel. Okay? If you guys have questions, just ask. We'll go to your questions. So let's start with Andrew. Andrew, quick introduction.
Yes, I'm Andrew Caples. I'm with a business development team responsible for machine learning and artificial intelligence on edge devices.
Andrew is from Meta. So when you think smart glasses or AR, VR, think Meta, right? Meta has maybe, Andrew cannot say it, but I can say it. Meta has maybe 95% share today on glasses. Yes, Chris.
Hi, my name is Chris Moore. I run marketing for the mobile business unit at Micron, focused on storage and memory inside the cell phone.
So, Nvidia stock would not be possible without memory. And Micron has been coming out with advanced high bandwidth memory. We won't be here without Micron. So thank you, Chris. Achin.
Hi, this is Bhowmik. I am Chief Technology Officer for Starkey. We are a medical devices company, and we make an edge computing devices called hearing aids. I'll tell you a lot more about that. I also teach at Stanford. I'm a faculty member with the Human-Centered AI Institute and Stanford Neurosciences Institute.
Mehak.
Yeah. Hi, everyone. Good afternoon, good evening. Thanks for staying for the last session. I'm Mehak Sharma. I run the Gemini product partnerships and growth team at Google. So have been working on all of the AI consumer products across search, workspace, and also Gemini chat product that we have. Delighted to be here.
Mehak, thank you for coming. I just got an alert that Google Gemini is available as an app on the iPhone. How many of you have an iPhone? Yeah, as of yesterday. So, thank you. Angela.
Oh, hello, everyone. I'm Angela McIntyre. I'm the Executive Director of the Stanford Wearable Electronics Program, and we help professors as well as students and postdocs take their innovations out of the lab and commercialize them. We do that through pitch events, through partnerships with other companies, and we span across the School of Engineering and the School of Medicine.
Thank you, Angela. So, I'm very excited about this panel because we have smartphones, glasses, earbuds, PCs, future of wearables. We will dig into each one of these. Let's start with, why is inference moving from the cloud to the edge? So who wants to take that?
Sure, I'll jump in. So there's many reasons why inference is moving from the cloud to the edge. Just to name a few, latency. Clearly there's use cases that are better suited for the edge, natural language processing, translation, voice assistance, ASR. These are all real-time type applications where you benefit from having the actual inference on the edge as opposed to transferring data to the cloud. But as you interact more and more with your device, transferring data for these use cases, it makes sense to keep the data on the device because more and more is learned about yourself, your behaviors. So privacy becomes another motivator for device inference. If you look at what's happening with apps that offer chat or group conversations, you're seeing more and more encryption, end-to-end encryption, to make sure these conversations are secure. So it makes it virtually impossible to do simple tasks like summarization or retrieval or search in the cloud. You have to do it on the edge because that's where the data is. And then lastly, cost, of course. If you can transfer inference from the cloud, the data centers, to the device, take advantage of the compute resources, the power, the memory resources on the device, it makes a huge difference in, as you look forward, your infra costs and your fiscal year CapEx costs. So that's just a few.
So latency, privacy, and cost. Other things you guys want to add?
I would add, first, completely agree with everything you said. And I would add personalization. I think for the mobile handset in particular, there is a ultimate next step, it's a few years away, when the hardware will be able to run a real-time LLM or SLM, running in real time with maybe Google Gemini. Nice product, by the way. Running in real time, being able to understand what you're doing based on where you are. It'll be able to collect data from your watch, from your hearables, from your glasses. It'll know, for example, that you're standing in a store and that earlier that day you volunteered to get your kids' snacks for the soccer game, and it'll remind you to go do that before you go check out. It'll know that you're driving in an area that you're not normally at and ask you if you're looking for directions somewhere. So it'll prompt you. Eventually your phone is going to know you better than you know your phone. All of that is going to require inference on the edge. It's going to require probably multiple SLMs running in parallel, in real time, interpreting data, having contextual awareness, and then driving that into a prompt that could go to the cloud to search for data that you can only get from the cloud, or maybe search on your device for that picture when you're standing at the dinner party and you're looking for the one thing of your kid and you don't want to spend 10 minutes scrolling your pictures. It'll find it for you right away.
So personalization, because your device has context and it has your data. Other things you guys want to add?
I'll just maybe highlight hearing devices as an example of, you mentioned latency and cost. So I'll highlight two of those. First, these hearing aids, hearing devices, these are tiny devices in your ear that are nearly invisible. In fact, I challenge anyone to tell if I'm wearing them or not. Those are small devices with tiny battery that needs to run for at least a day-long battery life on a single charge. We actually go for 2 days. Latency, human perception is unforgiving for latency. So for real-time signal processing, to enhance the sound as it's coming from the environment, you have to play it back sub-millisecond latency. So we can't afford to send signal off to the cloud and bring it back. So that's it. Those use cases on the edge devices itself require running AI on the device. But of course, we need cloud for amazing applications such as translation, transcription, setting a reminder. And your device is your conduit as your personal assistant. But heavy computation will be done on the cloud using technology.
Yeah, Achin, we'll come back to the use cases. Please.
I think I agree with all of the points. I think the thematic accelerators are similar across the board. The only thing I'll add is that one of the trends that is also happening with this is that enterprises are also looking very closely to how to move to edge, right? So the reason for that is productivity becomes a pretty major use case with Gen AI. It's very horizontal, so there's a need for abstraction layer that sits on top of corporate devices. And edge AI provides that low cost computation, low latency, privacy preserving. You don't have to send the data to a third party. So think about all of the corporate app developer tools that be connecting to your enterprise data, and your employee could actually take benefit of that, which was pretty blocked. Like, even when ChatGPT was launched, companies had blocked it, because of, all the privacy and security reasons. But there may be a path where if we move to edge and have SLMs that can perform enterprise-specific productivity tasks on device, and we're already seeing that and hearing that from a lot of our workspace partners. That's also one of the factors that's contributing. It's not a consumer angle, but it's more of an enterprise angle, yeah.
Yeah. You guys are missing one big thing. Yes, please go ahead.
Well, maybe you have one after this, but I was thinking about health and how our hearables as well as our smartwatch are gathering data about our health, our biometrics, how our body is doing. And one thing that's pushing us to use this AI for our health more is the difficulties that people have with the healthcare system, and maybe taking more advice from smart AI that can tell you if you're getting sick and maybe help you maintain your health better.
Yeah. What are they missing? They're missing one important thing. Oh, I'll introduce myself. Yeah. What are they missing? Offline. Yeah. So offline, good point. What I'm thinking is power, efficiency. Every time I go to Gemini or ChatGPT, it costs somebody 10 cents and it uses up cloud power. This is much more efficient. So to summarize, cost, latency, power, personalization, enterprise requirements. Health is a very good use case because it combines many of the things. Quick intro on me, Pankaj Kedia. I was early employee, started few businesses inside Intel and Qualcomm. When I worked at Intel, we were an iconic company. Just a joke. Now I'm just an investor. So thank you. Okay, let's go to use cases. I'll go with the smallest device and work our way up. Okay? So Achin, we'll start with you. What I wear in the ear.
Right. So again, I'll give these devices an example.
Yeah.
First, its core function is to do real-time signal processing. In doing so, what's latest trend is to use AI to decide real-time what signal should be amplified and what signal should be suppressed. For decades, hearing aids have been there for decades. The biggest complaint used to be that I can hear because you're amplifying the sound, but it doesn't help me understand conversations in a loud and noisy restaurant because the signal-to-noise ratio needs to be expanded with the device. That was not possible. It was a requirement, but it was not possible until the advent of power-efficient deep neural network. In fact, we have built in an NPU in the device itself on the processor to do that. So as a result, you're able to have superhuman hearing, is what I would say, not just recover from your hearing loss, but give you better hearing than normal person. But with the connected device, you can now treat this as your personal assistant. It can do translations where the translation is getting done on the cloud, delivered privately into your ear. And I was driving in, my devices were streaming Google Maps instructions into my ear. I could be streaming audiobook, phone calls. It's always there. You don't have to reach into your pocket and look out for something. So it's an example where AI is enabling you to go beyond your limitations. Memory reminds me of functions. It's bringing information to you and it's tracking my health as well. So that's the power of edge devices with AI.
Yeah, very interesting. Let's go to Andrew. Talk about glasses. Meta has been innovating in glasses for some time. What are the edge use cases for a smart glass or AR, VR?
I guess the way I would characterize it is that if you look at the machine learning models that are running on like smart glasses on the edge, segmentation models to be able to identify what's in your field of vision, classification models to classify it, occlusion detection models, automatic speech recognition models, tracking models, hand, eye. I mean, those are all the foundation that gives the smart glasses, makes them actually AI intelligent. If you look at like what Meta has released with Meta Ray-Ban glasses, from a hands-free perspective, you can call on your AI assistant, hey, Meta AI, play music, or you can connect with your family and friends, or capture the moment, taking video or images. Again, all without reaching for your cell phone. Or even with what Meta announced at Connect, Orion, where you're merging the digital world and the physical world, but you're not encumbered by a 2D display on your mobile device. Using a holographic display, you're using like the physical world as your canvas, and you're inserting 2D objects and 3D objects, anywhere, and this gives you greater awareness and understanding of your environment. So what I would say is that not all of this is, you're not able to do all of this on the edge today. Certainly there has to be greater advances in edge compute, SoCs in smaller models. That's something that we're working on. Meta released Llama 3.1 multilingual models, which are important for the edge. Meta released Llama 3.2 multimodal models with 1 billion parameter and 3 billion parameter models, which are ideally suited for the edge. But what I would say is that one of the more compelling use cases in my mind are the AI assistants. You're seeing them now introduced not only on mobile devices, but on AI PCs. And it's changing the whole paradigm, right? No longer do you need your keyboard or your touch screen to be able to access your device. Hey, AI assistant, what's on my calendar today? Hey, AI assistant, schedule a meeting. It's just making us more productive in my mind as these AI assistants become more personalized through the data and reasoning capability is added. They're going to be able to solve more and more complex tasks. And these are running on the edge. You do have edge devices running foundational LLMs, many of them Llama, with AI assistants.
8 billion people, 7 billion phones, 6 billion smartphones. Mehak, why should on-device compute move to the phone instead of the cloud?
I think, the use cases are pretty clear, right? I think from a consumer standpoint, anyone that's buying a phone or making a decision about the phone is looking at the camera features, right? So everything that's happening on camera, if you are trying to erase someone that you don't want in your picture, which Pixel does by erasing a picture, that is happening on device. If you are trying to, as a creator, if you're trying to, publish something on any of the channels like TikTok, Instagram, all of that is happening on device, right? There are obviously beyond just creator use cases, there are lots of video, audio use cases. A big one that we're seeing, especially with Gen AI, is live conversationality. So there has been a trend of people just talking to AI, and having the AI take a certain character. So it could be a person, Elon Musk, or anyone, or you could just take advice from them. And while driving to work, you just talk to them, about any topic. And so we're seeing really interesting trends. So I think all of this requires a lot of on-device compute, right? I think the way we think about phones is that phone is not just a device, it's actually a hub. And we look at phone as a hub and spoke model. So all of the devices that you have, they all get connected to the phone. So we are an enabling platform that is making sure that the developers have the right tools to be able to build the Gen AI application. So if they want to use an open weight model on edge, they can do that. And right now, those tools don't exist. So a big part of the effort that's going on right now is just because of the demand that we're getting from the developer community, right? So everywhere on the developer side, enterprise side, consumer side, there is so much pressure to just grow. And across all of the vectors that you mentioned, around deterministic latency or power or bandwidth, there are very specific benchmarks that we have to meet even for Gen AI. So we kind of view ourselves as the enabler on the platform. So there's been a lot of work that's going on, in making sure that happens. But, I think use cases are very consistent, speech generation, productivity, pretty much the same. But the demand is growing at a very exponential rate, again, because of the surface area of this technology being so broad and the widespread utility it has across all the tools is kind of making us build this abstraction platform that's able to handle that.
Chris, coming from Micron, maybe you want to add your perspective on the smartphone.
Yeah, first, we have a very smart panel. I'm agreeing with everything everybody's saying. So,
We can make it controversial.
yeah. For this one, I'd actually just like to ask everyone in the audience, if you, let's say I live in Redwood City, right? So I've got a pretty long commute to work every day just because of traffic. If I'm halfway to work and I realize I left my laptop at home, am I going to turn around and go get it? No. If I'm halfway to work and I realize I left my phone at home, I am going to turn around and go get it. So to me, that's the real simple answer why it's coming to your phone. Because your phone is the window of your life into so many things, whether it's to the internet, whether it's to social media, whether it's connecting with your friends, whether it's connecting with your glasses to your hearables. I think one of the great use cases is one you mentioned. Your phone is your hub. It connects to everything together. So in the future, I have my Garmin watch. I have it today, but someday I'll have my glasses, right? I'll have my hearables. My phone can actually go through and parse and see that I ate that steak at lunch, know how many calories are in it, know whether or not I ran, know what's going on with my heart rate that day, my blood pressure, collect all this together and give me a really comprehensive health report of what's going on, and may tell me whether or not I should have dessert at night, right? Thank you. So to me, it's all of these things coming together, and the fact that this phone it's not a phone. We call it a phone, but we all know that's like the least common use case. It's your hub. It's a hub of your digital life. Your digital life and your physical life are merging together. And it's going to make you more creative. It's going to make you more productive. It's going to make you healthier and make better decisions if you choose to.
So, Meta, Google, Starkey, Micron, all of you think long term. But Stanford really thinks long term. So, Angela, if you take out your crystal ball, we are talking about devices that exist today. Tell us the future of devices, the future of wearables, and how edge AI might come to these devices.
There it goes. Thank you so much. Yes, so looking out far, we can see that we're going to have devices that are really integrated more with our skin, with our bodies, more implantable. But having stretchable electronics that are just interfacing on our skin and our clothing that are almost invisible will be more of a trend, but we'll certainly need this hub to be able to make sense of all that data. So we might have use this phone less. I think we'll be having alternative form factors for phones. And back in 2016, Pankaj, we were talking about this when you were maybe back at Qualcomm. And you said the phone could be just the size of a credit card. And I agree with that. So it becomes more of a hub. You have your foldable display that can be put anywhere whenever you need it. You have your microphones and your hearing through your hearables. So that's that. You have all of these sensors that can be attached to your skin, and you can just forget about them. Maybe even implanted into our nerves to help us overcome some challenges that we have, or help measure our digestion better and get a good sense of what our overall health is. So that's kind of what the future is. Of course, AI will be integral to that, to making sense of it and our privacy.
Yeah, you're taking continuous glucose monitor to the next level. If I could have a patch that tracked all these things, it would be silly to go to the cloud and come back. My favorite use case, how many of you have been in a Waymo? Right? Think about it. When you're in the Waymo, it has to decide whether to slow down, change lanes, stop for some pedestrian. If you had to go to the cloud, come back, even if you have the best 5G connectivity, the round trip is too long. You have to make decisions on the spot in microseconds, like 10 microseconds. And that is edge computing. Okay? Let's say we establish this is going to happen. There are interesting use cases. Just watching time, so please keep your answers short. What is the one thing that would accelerate edge computing on the edge? Maybe let's give one thing each person.
Sure. Certainly on the edge, you have resource limitations. So making the models smaller would serve as an accelerant, right? Either through pruning, which compresses the models, or quantization, which reduces the bit precision, but actually increases the compute efficiency because int math is more efficient than floating point math, or the compiler tools that are being used. And lastly, I should say the compiler tools that are being used very efficiently to generate optimized code for the accelerators. All this is important, but more work needs to be done. The last thing I would say is that Meta released Llama 405 billion parameter models, which can be used to distill very accurate, very performant, smaller models that can be used on the edge. So a lot of work is being done, but more work needs to be done.
So smaller SLMs, smaller language model. Chris, one thing.
Well, first, from a technology point of view, a lot has to happen in terms of silicon and power to be able to run these things in your hands in real time where you don't kill your battery, right? So that's one. But I would say the one thing that really, and everybody's working on that, and we're trying to get there, but it's going to take time. The one thing that would really drive it is consumer demand. If and when there is a use case that we describe or that you see that you're willing to go pay for, that will accelerate the technology, and that will make companies innovate to get there even faster. Today, we live in a world of seamless innovation, where things just kind of slowly get better and better. Your camera's slowly better on your phone. Your battery life's a little bit better. Certainly, connectivity is getting better and better. But if there is a step function in that killer app, as everybody likes to talk about, that says, I have to have that, that is what's going to drive innovation faster.
Very good point. Use case, awareness, and compute capability. Achin, what would you add?
On the technology side, we're well on that path now, but there is insatiable hunger for fast and accurate models, trained with as much data as we can get our hands on, and we're doing that. And you mentioned the computational capability, tiny processors with embedded deep neural network accelerators, which we started with these devices now. Amazing performance improvement path that we are on, and we'd like to see that in the years to come.
Yeah. Mac.
That's a disadvantage of being the fifth here, because I think a lot of the big points have been covered. But I would say that, adding to a couple of points there, I do think there is still a lot of developer friction in actually building for edge and building for these applications. And we're constantly, so if you think about the two big ecosystem, Android and iOS, they're building all of these capabilities for their own OS. And a lot of the developer tools are not available for them to be able to build on these devices. So I think there needs to be a big effort in, across all of these hardwares, I think, to make sure that developers can be a part of it. Because I think the demand piece is already well on its way. There's a lot of work happening already on the hardware side. But I think developers who are a key enabler in the ecosystem definitely need more tools to be able to build on top of this.
Next question, I'll go this way. Sorry about that. Angela.
Yeah, well, having the ability to merge databases and having access to databases and having the data between the databases be rationalized is a limiter to being able to get AI to make useful inferences across different devices and your healthcare versus what you have on your phone or what you're seeing through your smart glasses.
Yeah, I would say security and privacy. If you want to run a small language model with your personal data on the device, that's paramount, right? Okay, so we have a couple of minutes. We'll do quick questions. You have a quick question? Okay, I'll come back actually. Let's do quick questions. So, no explanation, please, okay? Let's just give out a number. So, Angela, we'll start with you. In 3 years and 5 years, what percentage of inference will happen on the edge? 3 years and 5 years. Two numbers.
I could just speak about wearables because I can't speak about cars. Yeah. But so now it's 3 years and 5 years? 15 and 25.
Okay, Mehak.
Again, very use case specific and smartphone specific. I think for sort of less complex to medium complexity use cases, it's going to be in 3 years easily 40 to 50% and going to 75% in latter years.
Okay, Mehak is winning. Achintya.
So it depends on the definitions. If we say LLMs that are large, it's going to be 100% of the cloud. But if you take a broad definition of AI, I'm totally with you, I think it's going to be 50% very soon. Every edge device will run AI, and it's going to be 80 or higher percent in 5 years.
Okay, Chris.
Again, it comes down to definition because there's a lot of AI running in your phone today when you take a picture when you're using the phone. So if you consider that, the number is much, much higher. But I think your question is more about generative AI, foundational models. And so I would say 70%, including automotive, in 3 years, going to 80 to 90% easily in 5.
Okay. Anything you want to add, Andrew? No? Okay. So, today we talk about AI PC, AI smartphone. If we get to 50 and 75%, every smartphone, every PC will be an AI device, right? Okay, let's do something fun. You cannot talk about your companies, okay? Angela, we'll start with you. I know Stanford is number one. If I keep out Stanford, which other institution is innovating the most in AI, Gen AI space?
Well, it would probably be MIT.
MIT, okay. So of course Google is winning. Mehak, what is the number 2 company on top of your list?
I will respectfully decline to answer this question. I'm just kidding. I think it's too early to say, honestly. The way I think about this is that, there were 80,000 applications created in the last 18 months. Our ability to judge in the short term is very limited because we're still in very early stages. So I think the real signals will start coming in 3 to 5 year horizon, right? There are some obvious ones, that everyone knows about, but I think really the winners will start to show in 5 years from 2022 and still very early to predict who's going to win.
Okay. Achin told me Starkey is the number 1 hearing aid company in the world. So you are winning.
Yeah, we are.
Who's the next one?
So I'll take and I truly believe in this. I think we're accomplishing some amazing fits in the medical device industry. I hope and I'm confident that some of these elements will just totally transform what you know today as consumer devices. Yeah. So as a medical device, we can make smaller impact. 1.5 billion people have hearing loss, hundreds of millions buy hearing aids every 1 or 2 years. But the number and volume of consumer devices is staggering. So the work we're doing, I'm pretty sure is going to float the consumer electronics
Chris, I'm a Nvidia and Micron shareholder.
Yeah.
What is the next stock I should buy?
I've actually put a lot of thought into this question. My initial answer probably would have been Google. But as I think about it more, it might be Apple. Apple, with their vertical integration, the amount of cash that they have, if their foray into Apple Intelligence really starts driving some homegrown innovation, they are uniquely situated to position their consumer products, their entertainment products, to really drive the consumer. They have so much cash and the ability to scale so quickly if they get it right.
If we had more time, I would love to have an Apple versus Google discussion. But we don't have time. Andrew.
Well, I'm not going to name a company that I think will be leading the charge. I know Meta will certainly be in the mix, but what I would say is the ultimate winner is going to be the end user. I mean, if you think about it, anything with an MCU or above is going to be doing, is going to have Gen AI capability to some degree. It's going to make us more connected, more informed, more productive, more aware. I mean, this is IoT devices, wearable devices, AI PCs, tablets, the whole mix. So this is all coming, and super excited to see this roll out.
Okay. So what we are going to do is, first, give them a big hand. Thank you, everyone. I called them 2 weeks ago, and we put this together very quickly. Now, Mehak has to drive to San Francisco, and Achin has a meeting. Angela can stay for a few minutes. Can you guys stay for a few minutes? You have a flight. You have a dinner, 5 minutes. Oh, okay. Yeah? Okay. 5 minutes, guys. We'll take quick questions. Yes. Make it quick. Okay, that was a long question. You nudged out Mehak. Okay. Thank you, Mehak. Give Mehak a big hand, please. Okay, keep your questions short so we can take more of them, right? But, Andrew.
So what I can say is that certainly it's well known that Meta releases Llama models as open source. And these include models as large as 405 billion parameters, as small as 1 billion parameters. But not all the work that we do internally at Meta is released open source. You could probably understand why. And so what I can share with you is, I can't share with you the actual size of models that we're working with, but I can definitely share with you they're much smaller. So...
Okay, guys, let's keep moving. Quick questions.
I'd actually like to address that one because I'm in memory and all of this is memory limited, right? So we're really acutely focused on Llama 2, Llama 3, and it's interesting if you look at Llama 3 when it first launched, it was about as effective for a lot of search queries as ChatGPT 3 was when it first launched 3 years earlier. So the models are definitely getting smaller, no doubt about it. I think the key is actually the effective training of the models based on what you're trying to get out of them. So more than whether it's 8 billion parameters, which is kind of where we're looking at today a lot in the phone, based upon the technology available today, getting them down to 2 or 3 billion parameters and then having multiple ones running at a time, I think is where the direction is going.
Okay, one more. Yes. So I'll repeat the question. use of AI in sensing emotions. Emotions and coaching. Yeah, let's keep it simple. Who wants to take that?
Oh, thanks. Yeah, so, yeah, emotion tracking, and it's going to become more popular because we're getting more anxious, and I think that, well, it's a good area to get into, but it's very difficult to actually be able to know enough about the person to make good suggestions and to give them great coaching. And it's also a medical type of issue. Do you want to be taking responsibility for somebody's depression or perhaps suicidal ideation? So there has to be a good mix of health versus, getting into the medical side. Did that help? Coaching for salespeople.
Let's take that offline. It's very specific. Yeah, go ahead. Andrew. There's no press in the room.
So if we think about it from an edge perspective, right? Apps developers, they want to add Gen AI intelligence. There's no question about it. Well, how do they do that, right? They need to build novel use cases that differentiate them from everybody else. If everybody's using the same models, they don't have control over the model, it's hard to create differentiation. So what's the impediment? Well, you have resource limitations on edge devices. Consequently, you can only run a limited number of LLMs. So if every app developer out there wants to incorporate their unique Gen AI feature, they want to be able to choose which LLM, open source or commercial, is best suited, right? And it doesn't matter if it's open source or commercial. One may be better suited than the other. The point, though, is that there has to be some sort of democratization of the hardware to allow the app developers to choose what LLM they can run. And without the democratization, they're not going to have a choice. So that's the way I would answer it.
Okay, I don't want Andrew to get upset with me if he misses his flight. So let's give them a big hand.